Have you ever looked up at a plane, its wings slicing through the sky, and felt a sense of wonder? That feeling, that mix of curiosity and awe, is something humans have felt for generations. And in that moment, maybe you've asked yourself, how did it get there? How does something so massive, so heavy, manage to lift off the ground and glide effortlessly through the air? I mean, think about it. This giant hunk of metal filled with people, luggage and fuel somehow defies gravity. It doesn't just float, it soars, cutting through clouds, dancing with the wind and chasing the sun across the sky. But before any of that could happen, before the engines roared and the wheels left the runway, it all started with something simple. A dream, a vision, a spark of imagination. Every airplane, from the nimble two-seaters to the massive intercontinental jets, began as a thought in someone's mind. A what if, whispered into the wind. What if we could fly like birds? What if we could cross oceans in hours instead of days? Just like when you doodle a picture in your notebook, engineers begin with lines on paper. They sketch wings, engines, and fuselages. They imagine how air will flow, how weight will be balanced, and how the plane will respond to the forces of nature. Sometimes it starts with something as simple as a paper airplane, a folded piece of paper tossed into the air, teaching us about lift, drag, and the joy of watching something we made take flight. From there, the ideas grow. Engineers and designers collaborate, imagining the plane's shape, its size, and its mission. Will it carry passengers across continents? Will it deliver supplies to remote areas? Will it explore the edge of space? They calculate how far it will fly, how fast it will go, and how safely it can land. Every detail matters, from the curve of the wings to the materials used in the frame. Prototypes are built and tested, in wind tunnels, in computer simulations, and eventually, in the open sky. Each test brings them closer to turning that dream into reality. These early ideas, fragile and uncertain, are the seeds from which magnificent flying machines grow. And every time a plane takes off, it carries with it the legacy of those dreams and the promise of new ones still to come. Once the initial idea takes shape, the real work begins. That spark of inspiration must now be translated into something tangible, something that can be built, tested, and eventually flown. This is where the magic of engineering meets the precision of planning. It's time to create detailed plans, meticulous drawings that capture every curve, every bolt, and every aerodynamic surface of the aircraft. These aren't just sketches, they're the foundation of the entire project. These plans, called blueprints, are like recipes for building the airplane. They include everything from the wingspan to the placement of rivets, ensuring that every part fits together perfectly. They show the exact measurements, angles, and components of every part. Precision is key. Just a few millimeters off could mean the difference between flight and failure. But it doesn't stop there. As technology has evolved, so too has the way we design aircraft. Paper blueprints are just the beginning. In our modern world, engineers use powerful computers to create virtual models of the airplane. These digital designs allow for a level of detail and flexibility that paper could never offer. With just a few clicks, they can adjust wing angles, test different materials, or simulate how the plane will perform in various weather conditions. These three-dimensional models can be rotated, zoomed in on, and even tested in simulated environments. It's like having a virtual wind tunnel at your fingertips. Engineers can simulate stress tests, aerodynamic flow, and even emergency scenarios, all before a single part is manufactured. This helps engineers to identify and fix any problems before even a single piece of metal is cut. It saves time, money, and most importantly, ensures safety from the very beginning. Airplanes are made from some of the most advanced materials on Earth. One such material is carbon fiber, which is lighter and stronger than traditional metals like steel. It's like a super strong fabric that can be molded into complex shapes. Another important material is aluminium, a lightweight metal that is resistant to corrosion. By combining these materials in clever ways, engineers can build airplanes that are both strong and light, allowing them to fly efficiently and carry heavy loads. With the blueprints and materials ready, it's time to start building. The airplane is constructed in sections like a giant jigsaw puzzle. The fuselage, which is the main body of the plane, is built separately from the wings and tail. Each part is carefully assembled using giant machines and skilled workers. The wings, for example, are built around a strong internal structure called a spar, which helps them to withstand the immense forces of flight. Building an airplane requires incredible precision. That's where technology really comes in. Computer-controlled machines called CNC machines cut and shape metal parts with, incredible accuracy. Another exciting technology is three-dimensional printing, which allows engineers to create complex parts directly from computer models. This technology is, honestly, revolutionizing the way airplanes are designed and built. Section 6. Testing. 1, 2, 3. Throughout the entire building process, every single part of the airplane is, rigorously tested. Engineers use X-rays to check for cracks, stress tests to simulate flight conditions, and even wind tunnels to study how the plane will behave in the air. This constant testing ensures that the airplane is safe and reliable, meeting the highest standards of quality and performance. Section 7. From skeleton to sophistication. With the airframe complete, it's time to install the airplane's vital organs. This includes the engines, which provide the thrust to get the plane airborne, as well as the complex network of electrical wiring, hydraulic systems, and flight controls. The airplane's interior is also fitted out with seats, galleys, and entertainment systems, transforming the empty shell into a comfortable and functional flying machine. Section 8. Flight of fancy. Before the airplane can carry passengers, it must undergo a series of rigorous flight tests. Experienced test pilots put the plane through its paces, evaluating its handling, performance, and safety. These tests are crucial to ensure that the airplane meets all certification requirements and is ready to take to the skies with confidence. Section 9. Ready for takeoff. Finally, after years of design, engineering, and testing, the airplane is ready for its debut. This moment marks the culmination of countless hours of collaboration between engineers, designers, technicians, and test pilots. Every bolt, every wire, every panel has been meticulously crafted and inspected to meet the highest standards of safety and performance. Behind the scenes, teams have worked tirelessly, reviewing blueprints, running simulations, and solving complex problems to bring this aircraft to life. It's not just a machine, it's a symbol of innovation and teamwork. Now, it's painted in the airline's livery, proudly bearing the colors and branding that will soon become a familiar sight in skies around the world. It's also been assigned a unique registration number, its official identity in the global aviation network. As it rolls out of the factory, it's more than just a new aircraft. It's a testament to human ingenuity and the enduring dream of flight. This rollout is a ceremonial moment, often celebrated by the entire team that brought the aircraft to life. The next time you see an airplane soaring overhead, take a moment to think about the journey it took to get there. It's easy to forget the complexity behind what seems like a routine flight. From the first spark of an idea to the roar of engines at takeoff, every aircraft carries with it a story of ambition, perseverance, and precision. It began as a simple sketch on paper, evolved through digital modeling and wind tunnel testing, and was shaped by the hands of skilled workers. Each phase brought it closer to becoming a technological marvel. Now, with pilots preparing for its maiden flight, systems being checked, and final inspections underway, the aircraft is ready to fulfill its purpose. Ready to connect people and places around the world, bridging cultures, economies, and families one flight at a time.